Statistics. It's not just about crunching numbers. Did you know that a single statistical error once caused a $125 million Mars orbiter to crash because one team used metric units while another used imperial?
Oh, wow. That really shows how interpreting data correctly can have massive real world consequences. It's not just about the numbers themselves, is it?
That's exactly right. We're surrounded by data every day, and there are two main ways we make sense of it all: descriptive statistics, which tell us what's happening right now, and inferential statistics, which help us predict what might happen next.
Hmm. So it's like the difference between taking a snapshot versus making an educated guess about the future?
Well, think of it this way: when you check your fitness tracker, it might tell you that your average daily steps are 8,000. That's descriptive statistics at work. But when it predicts you'll reach your monthly goal based on that pattern, now we're in inferential territory.
That makes so much sense. But how do we know when we can trust these predictions?
That's where things get really interesting. We use something called hypothesis testing, starting with two possibilities. Either there's nothing special happening, the null hypothesis, or something significant is occurring, the alternative hypothesis. And then we use tools like p-values to determine which is more likely.
I've always wondered about those p values I see in research papers. They seem to carry so much weight.
Oh, they do. And here's the fascinating part: that magic number of zero point zero 0.05 that scientists use, it's actually pretty arbitrary. It was suggested by statistician Ronald Fisher in the 1920s, and somehow it's stuck. If your p-value is less than that, we say the results are statistically significant.
So, if I'm understanding correctly, it's like having a 95% confidence that what we're seeing isn't just random chance.
Exactly. But, and here's where it gets tricky, we can still make mistakes. There are type 1 errors, where we think we found something significant but we haven't, and type 2 errors, where we miss something that's actually important.
Like when a medical test gives a false positive or false negative.
Precisely. And that's why we often use confidence intervals. Instead of saying, this treatment works exactly 80% of the time, we might say, we're 95% confident it works between 75% and 85% of the time. It's more honest about the uncertainty.
That reminds me of weather forecasts. They don't just say it will rain, they give us a percentage chance.
And you know what's really cool? Many things in nature follow what we call a normal distribution, that famous bell curve shape. Height, intelligence, even measurement errors tend to cluster around an average with fewer extremes on either end.
Though not everything follows that pattern, right? Some things must be more skewed.
Oh, absolutely. Think about income distribution. It's usually skewed right, with most people earning moderate amounts and a few very high earners pulling the average up. Or think about customer complaints. You can't have negative complaints, so that data is bounded at zero.
These concepts really do show up everywhere once you start looking for them.
And that's what makes this so powerful. Whether we're developing new medications, predicting election outcomes, or just trying to understand our own fitness data, these statistical tools help us make better decisions based on evidence rather than gut feeling.
Though I imagine we still need to be careful about how we interpret and use statistics, right?
That's such a crucial point. Statistics can be incredibly powerful, but they can also be misleading if not used properly. It's like having a sharp knife. It's an amazing tool, but you need to know how to use it safely.
So, what would you say is the most important thing for people to remember about statistics?
I'd say it's understanding that statistics isn't about eliminating uncertainty. It's about quantifying and managing it. Whether we're using descriptive statistics to understand what's happening now, or inferential statistics to make predictions, we're always dealing with probabilities, not absolutes.
That's really what it comes down to making better decisions in an uncertain world.
And in today's data driven society, that's becoming more important than ever. Understanding these concepts isn't just for scientists and mathematicians anymore. It's becoming an essential skill for everyone who wants to make informed decisions in their personal and professional lives.